I've begun by importing an IGES model of an engine cowling. I'm just going to use PowerShape's information panel to tell me exactly how many surfaces there are and the size of the part. You can see I have 1,300 surfaces and the part is 1.19 meters in diameter and 500 millimeters in length. The first step is simply to select all the surfaces and convert to a solid. Once I have a solid, my next step is to check its quality. To do this, I use a unique tool in PowerShape, the SolidDoctor. The SolidDoctor has now located and highlighted all of the faults in the solid. I'm going to begin with these two small gap faults. So I'm just going to isolate the two gap faults and select them individually. I'm going to ask the SolidDoctor to repair those automatically. Both of those faults have now been fixed by re-intersecting all of the surrounding faces to correctly close the solid. The next fault is on this large main surface around the front of the model. I'm going to repair this by selecting the surrounding faces and extracting those surfaces and editing them manually. To make it easier to see what is going on, I'm just going to blank the rest of the model temporarily. And it immediately becomes obvious what has happened. The part at some point has been changed by adding a fillet, but the underlying surface has not been correctly trimmed. I can simply select the trim position, remove the segment of surface that I don't want, and simply delete it. I can now take my repaired surfaces and put them back into the main solid. I am now going to completely recheck the solid to see only the faults that remain at this point. I now have just one fault remaining. Again, this is a job for the automatic repair tool, which will re-intersect the surrounding faces to give a better fit of the surfaces. I will now recheck the solid and the part is now repaired and ready to go to manufacture. So from imperfect imported IGES data to perfect Parasolid using PowerShape and the SolidDoctor.